and this way we get two formula. Limit theta tend to 0, cos theta is equal to 1, and limit sin theta is equal to 0 is 0. Now, if a problem limit theta tend to 0, sin theta upon theta, for this value we expand the series of sine. We expand the series of sine. We know series of sine x is equal to x minus x cube upon factorial 3 plus x5 upon factorial 5, x7 upon factorial 7, and so on. Expanding the we know sin x is equal to series expansion of x minus x cube upon factorial 3, x5 upon factorial 5, x7 upon factorial 7. Expanding the series of sin theta will get theta is equal to theta cube upon factorial 3 plus theta 5 upon factorial 5 minus theta 7 upon factorial 7 divided by theta. If we take eliminate theta from numerator and denominator, will get 1 minus theta square factorial 3, theta 4 factorial 5, and theta 6 factorial 7, and so on. And this theta is eliminated. We will find limit theta tend to 0, 1 plus theta square factorial 3, theta 4 factorial 5, theta 6 upon factorial 7. Putting theta is equal to 0 will get 1. This way we can prove theta tend to 0, sin theta is equal to 1, where theta is any angle. Theta is any angle. Similarly, we can prove this is for tan theta upon theta. We can write theta tend to 0, sin theta upon theta 1 upon cos theta. And we know if product of two functions, we get first sin theta upon theta and limit theta tend to 0, 1 upon cos theta, and this is equal to 1 and 1, this is 1. In this way we can prove theta tend to 0, tan theta is equal to 1. So for trigonometrical function we will find four formula. Theta tend to 0, sin theta is equal to 0, limit theta tend to 0, cos theta is equal to 1, limit theta tend to 0, sin theta upon theta is equal to 1, limit theta tend to 0, tan theta upon theta is equal to 1. Basic four formula. With the help of these formula we can solve any trigonometrical function. You see some question, limit x tend to 0, sin 2x upon x. इसकी लिमिट निकलनी है. फार्मूला हमें मालूम है, लिमिट थीटा टेंड टू 0, sin theta upon theta is equal to 1. Here in the place of theta 2x, for that we make denominator 2x. For 2x we multiply 2. 2 is constant, we take above, so limit x tend to 0, sin 2x. In the place of theta here x, 2x, and we'll get, adapting this formula we'll get 2. In this way we can do the trigonometrical function of the limit. We use the trigonometrical functions of the limit. One sided limit. Write this I have already explained in the example. Right hand side limit. We say that the right hand limit of fx at a is a if fx a limit x tend to a plus, this a plus, so we are taking right hand side limit equal to a, or limit x tend to a plus fx is equal to a, or f a plus 0 is equal to a. Working rule for finding limit. Limit x tend to a plus fx, replace x by a plus h and take the limit as s tend to 0. Left hand side limit. Left hand side limit. We say that the left hand side limit of fx at a is b if fx is b when x tends to a through the values less than a, and we write limit, ये अपर माइनस सोर्स लेफ्ट हैंड साइड लिमिट fx is equal to b or limit x tend to a minus fx is equal to b or f a minus 0 is equal to b. Working rule for finding limit x tend to a fx, replace x by a minus h and take the limit as s tend to 0. This if right hand side limit equal to left hand side limit, we can say function is continuous. Limit of a function. Limit x tend to a fx is equal to l if limit x tend to a plus fx and limit x tend to a minus fx is also L. Conclusion limit exist and function is continuous. Function is continuous. However, if limit x tend to a plus fx not equal to limit x tend to means left hand side limit, we say that limit x tend to a fx does not exist and function is not continuous, function is discontinuous. Function is discontinuous. In this way we can explain the continuity of a function. Continuous function continuous function a function fx is said to be continuous in a open interval a b if it is continuous at each point of AB, f is continuous at A limit x a plus fx is equal to fa. Second, f is continuous at B if limit x tend to B fx is equal to B. Third, f is continuous in closed AB if it is continuous at A, at B, and at each point of A, B, each point of A and B. some concept of continuous function. Continuous function. A function fx is said to be continuous if it is हर डोमेन के लिए continuous at each point, continuous at each point of its domain. Like limit, here also the concept of algebra of a continuous function. Every constant function is always continuous, क्योंकि उसमें कोई चेंज आएगा नहीं, अनडिटरमाइंड आएगा ही नहीं, कंटिन्यूअस. ये ऑब्जेक्टिव के लिए आपको ज़्यादा यूजफुल होगा. सेकेंड, I have already explained types of function. Identity function is always continuous. Continuous. Third, if f and g be separately continuous function, then f plus g is also continuous. B, f minus g is also continuous. C, if CF is continuous where C is any constant. Constant means 2, 3, any fixed value. D, f into g is also continuous. F upon g is also continuous. At these points, except where denominator never be zero. Dx is 0. Fourth point, every polynomial function is continuous. Every rational function is also continuous. For types of function, you see my previous lecture what I've done. These the concept of limit and continuity. You do different questions of limit and for practice for any books and problems which I have given. Thank you. It is my lecture of limit and continuity, useful for BSc as the elementary mathematics, basic mathematics in forestry also covered in limit. Thank you.